Actually, before I get going, just a sort of a reminder, you have both the final exam and the course project due at the end of this week. And we, aside from the administrative fact that the course project is due, from a practical perspective too, we're going to be doing some maintenance on the server over the weekend. It shouldn't cause any files to disappear, but it's certainly safest if you can finish up everything before the weekend. And again, that's aside from the fact that it's due anyways on Friday. So please don't forget to do that. The material that we're covering this week, of course, is not on the final exam. So this is sort of like your dessert, hopefully. It's, I hope it will be some combination of interesting and useful to you. What I'm going to do is, let me go to the book for a second here. I'm going to talk about grid graphics. And I don't know that I'll do this for the whole week. I may, on Friday, I may switch to a couple other miscellaneous graphics topics. But I thought it was worth delving into grid a little bit, even though, as I said in the book here, in your day-to-day work, it's often, you're probably often not going to find yourself using grid because it's sort of, it gives you an amazing level of control, but it gives you so much control that you typically don't want that degree of control, because the trade-off of that control is you have to specify everything on your own. And it's kind of really getting down to the graphical nuts and bolts. But the reason I thought it's good to spend some time on it nonetheless is I describe it as kind of like a fisherman learning to swim. You know, you kind of hope you don't need to use that skill every day, but if you ever fall in the water, it's good to know. So, and I think you'll see a couple places where it's immediately practical, and then hopefully it will just get you over any fear you might have of diving into it if you do have curiosity and if you do want to learn more on your own. As if you go back, if you recall what we talked about back in chapter 2 here, grid is the foundation for provides the foundation for lattice. So lattice is programmed using grid basic functions. And there are a number of other important graphics packages that are also built on top of grid. And I think I mentioned back in chapter 2, one of the more important ones is one called ggplot, or let's see, it's ggplot2 actually. And unfortunately, we don't have time to go into ggplot2 in this course, but that's a useful graphics package as well. So whether you're using lattice or ggplot2 or one of these other ones, because they're all built on grid, like I said, it's helpful to understand a little bit of what's going on under the hood. So with that as the motivation, let me dive in a little bit here. I'm going to try to cover a couple basic grid concepts. One of them is the concept of the grid units. And there's a couple types of units that I list here that we'll look at. Another one is the concept of viewports, and another one is the concept of layouts. Those aren't all the important grid topics or concepts, but that's a lot of them. If you're curious and you want more information, you certainly can't go wrong by buying the book by Paul Murrell, who wrote the grid package. Okay, so So having said that, let's switch over to the code. I'm working with advancedgraphics.r. And I know I've done this one time before. I accidentally left you with this chunk number 1. Just get rid of that. You don't want to do that. Don't submit that piece. Go ahead and save that. So let's load the library. And I actually, to tell you the truth, I don't remember if you need to explicitly open up a grid new page. Let's just try this. If I just give a grid command without opening up a grid window, device, it does work. Okay. But this grid new page is just a way of when you're drawing in grid, that'll, of course, create a new page, so it'll clear whatever you have. So, like I said, grid does really basic things like plotting text. That's what we did there. By default, it's going to put stuff right in the middle. You can give it coordinates. And by default, with text, the coordinates are a proportion of the distance across the screen. So 10% across the x-axis and 10% up the y-axis. So let's look at that. Okay. This is just another example here of, just to show you it plotted somewhere else. Oops. L. And now on this line 26 here, what I want to start to show you is the utility, basically, of this concept of grid units. So when we specified the coordinates on lines 24 and 25, we were using these relative units called, you'll see in a second, NPC units, which stands for normalized parent coordinates, which again just means a 0-1 scale, and that's just the default. But you can specify units, you can specify different types of units. So on this line 26, I'm going to continue using NPC coordinates, or NPC units, for the x-axis. So that's 10% of the way across the x-axis. But now for the y-axis, I'm going to use a different type of unit. I'm going to use inches. And you can see it's plotted just a little bit above the red down there, which happens to be the way that I have this device sized at the moment. 1 inch happens to be about 10% of the way up. But if I resize the device by just scrunching it down this way, okay, 10% now, the red is still 10% of the way up. It's 10% of a different total distance. So that 10% is now 10% of less of a total distance. Whoops, sorry, let me get rid of my tasks. But what's in gray is a solid inch up. No matter how I have the device sized, that gray hello again, or hello again, yeah, is going to be 1 inch up. So that's a fixed type of unit as opposed to a relative type of unit. So that's nice already, that you can kind of mix and match fixed and relative units of different types. And if you look for the help page on unit, you'll see all the other types of units you can use, like centimeters and so forth. Where it starts to get even more interesting is you can do arithmetic with a combination of relative and fixed units. So I can say, like I'm doing here on line 27, I want to go 10% of the way up the page using these relative NPC units, and then on top of that 10%, which is a relative amount, I want to go 1 inch beyond that. And that kind of arithmetic, if you've ever tried it by hand, it's not rocket science, but it's a real, best way I could say it is a real pain in the ass to do that by hand. So Grid has this very nice way of doing this sort of unit arithmetic so that you don't have to worry about all the kind of linear transformations from one unit to the other. How does, so I just see a question from Jeffrey, how does the position work with NPC in output for PDF, for example? So if you're writing to a file-based graphics device, like if you're writing to a PDF file, NPC will be the same way. So that PDF, when you open up a PDF device, by default, I think it's something like 8 inches by 8 inches or something like that. Or if it's not, you can specify the dimensions of your PDF device. And let's say you made it 10 inches by 10 inches, and you said NPC equals 0.1. Well, that would be, for that particular device, it's going to be 1 inch up. So it works with PDF the same way it works with any other device. And PDF, when then you've made that figure in PDF. Then once you rescale the PDF file using a PDF reader, well, then all bets are off because that's a different type of scaling. But if you open up the PDF file in its default size, then everything will just work as expected. So I don't know if that answers your question. I think you can figure it out pretty quick by just playing around with it, and you'll see what I mean there. Okay, all I'm doing on this line 28 here is to point out that, actually I'm doing a couple things, I guess. When you add points with Grid, the default units are different. So when we're adding text up here, our default units, so like up here on line 25, we didn't specify whether these were NPC units or inches or anything like that. So it just picked a default type of unit and it said, okay, when you write 0.9, you must mean 0.9 NPC units. That's so NPC is the default unit associated with grid.text. With points, it's different. The default unit when you're drawing points is something called native units that we'll get to in a second. But if we want to still use NPC units, we can just specify that explicitly like we do here. And now I'm adding a point 90% of the way over and 90% of the way up. Okay. Okay, so Jeffrey's following up on the question of the PDF file. So if you export it, it will be just what the screen looks like. I don't usually use the export tool here. I usually do it by command line, but we could take a look at that. Save plot as PDF. Let's see if it, okay, so when we save it as PDF, you can specify, I guess it seems like what it's trying to do here is pick dimensions for the PDF file that are similar to what's shown on your screen. I'm just going to do a quick test here. I bet if I resize this so that it's square, and now I try and export again, Ah, okay. Well, so I'm surprised that these are the default dimensions that it's giving to the PDF file, but it's going to write it out as a 8.5 by 11. Okay, 8.5 by 11. That's because that's the standard paper size. But if we wanted to, so we could just leave it like that, and I don't think in that case it's not going to look exactly like what's on the screen, because the screen here is not 8.5 by 11, and well, we might as well just try it, and you'll see that it'd be easier to talk about when we're looking at it. So let's just call it rplot.pdf. Put it in my advanced graphics directory. And I'll view it after saving. Okay, so what has happened here? It has taken my what I saw on the screen, which was more or less a square, I don't know, 4-inch by 4-inch square, something like that, and it spread everything out to 8.5 by 11. The relative coordinates are still relative, so this point up here is still 90% of the way over, and it's 90% of the way up, so that changes. But the fixed coordinates, like this gray hello again, that's still exactly 1 inch up from the bottom. So, okay, if you try to copy the picture from the clipboard, to be honest, I'm not sure what would happen when you do it via the clipboard. But the general principle is, let's see, when you copy it from the clipboard, yeah, I don't know to be honest. But again, the general principle should be, in any event, that relative coordinates are going to be relative to the total available space, and fixed ones will be fixed. I can, if that doesn't seem to work as advertised, maybe just follow up with me on the course website, and we can look into that in more depth. But that's what I would expect to happen. Okay, there's a function we'll be using a lot here. It's not so important in this particular case, but if you just say grid rect for grid rectangle, it's going to draw a rectangle around the current plotting area that you're working with. And what that actually is, it's something called a viewport, and we'll get to viewports in a second. It's pretty subtle, but I just added a square around the whole plot here. I can make it more obvious if I do something like, say, LWD equals 4, line width equals 4. Now you can see a little bit more of a box here. I use this when I was trying to figure out grid. I used this grid rect a lot in order to just figure out what my frame of reference was. And so I'll come back to that concept. Okay, so in fact, I'll get to that concept right here. So in chunk number 5, let's start drawing on some new space here. So this will clear everything off. And now there's something that's automatically active when you when you do a grid new page, and it's called the current viewport. And if I just ask what the current viewport is, I get this output here that says basically that I'm in some sort of root viewport. And that, you can think of that as a piece of paper that's on your desk and it's blank, okay? And you can draw directly onto that viewport like we were a second ago. Just like you could draw directly onto that piece of paper. Or the way it usually works is you add sheets of paper, or in some ways it's maybe better to think of them as transparencies. You add transparencies on top of the one that's already there. And then you can draw a little bit on the transparency that you just added, and then you can add another transparency on top of that. And you can keep adding them. And each one can have a different coordinate system. And again, what that allows, what the value in that is, it allows you to work in a lot of different coordinate systems without doing all the arithmetic by hand to translate from one coordinate system to another. So let's try to get a handle on what I mean by that. So, all right, I'm going to clear it all again with grid new page. I'm going to push on a viewport now, which is going to take up the same amount of space as what's already there. So I've already got this viewport that takes up my whole screen device space. And this new one that I push on you can think of it as a transparency that's just as big as what's already on the table. But this new one's going to have a scale associated with it. It's going to have an X scale from 0 to 10 and a Y scale from 0 to 10. And what that will allow me to do is, from then on, when I use what's called native coordinates, so this could say here, this is the default, but I could say default units equals native, which is what I would get by default anyway when I'm doing grid points. But when I say native units, what that means is the coordinate system that was specified up here. So now if I say plot, give me a point at x coordinate 6 and y coordinate 7, that means on this 0 to 10 scale. So I'll do that. And then just to show you that that works, we can also plot another point. I'm going to use a different plotting symbol. Now I'm going to use a cross instead of a circle. But this time I'm going to use NPC units, the relative units that we used before, at 0.6 and 0.7. And of course that is going to be in exactly the same place, but two different ways of specifying the units. So that's that, okay? So now we've seen three different types of units. You've seen NPC, which is the 0, 1. You've seen native, which is basically user defined, like I did here. And you've seen fixed units like inches. All right? Any questions up to here? Okay, let's try to start to do something a little bit more practical. I'm going to set the seed here just so I get the same data that I had whenever I made the book. I'm going to clear the page again. I'm going to make some fake data. Using R-norm, 100 random normals for X and 100 for Y. And now what I'm going to do is, I'm not sure, you've probably seen the function range by now, but I have this X column and this Y column, and range just tells me the minimum and the maximum value of those X values, and same on the next line. So what I'm going to do is I'm going to push on a viewport. Again, think of it as another transparency where the X scale is defined as the range of the X values, and the Y scale similarly, okay? Now once I do that, now I've got a coordinate system where I can plot those. If I just want to plot the x and y values, I could do that with grid.points, or I can use some of the tools that we've already used with the lattice library, and I'm going to do that because this kind of hopefully shows you the connection with some of the stuff you already know. So I'm going to load the lattice library, and now I'm going to use a lattice function, panel.xyplot, to make my scatter plot within this grid viewport that I just made. So go ahead and run that. And this is basically, so you're used to seeing this function, panel.xyplot. You're used to seeing that do its thing within a lattice panel. But all it is a set of drawing instructions that are written using the grid language. So it can work outside of a lattice plot, which is what's happening here. Now, when you do that, it's fairly primitive, so a lot of the nice things that XY plot was doing for us aren't getting done anymore. And you can see one of them is, for starters, you don't have axis labels, but also you look on every edge of this plot region, you've got half a point. This is the minimum. This is the point with the minimum x value, and it's centered exactly right on the edge. And here's a point with the maximum y value, and it's centered right on the edge. So there was no buffer around these points here. There was no margin. And as you do this, as you start, you see grid for the first time, at least I did, and I thought, oh wow, now I've got all this flexibility that I can take advantage of. But when you start trying to use it yourself, you come to appreciate all the nice things that these high-level plotting functions were doing for you. That can be quite a bit of work to do by hand. Anyway, this particular thing of padding the edge of a plot is pretty easy. You could probably, you should be able to write your own function to kind of expand the margins as necessary. But I'm going to be lazy, and I'm going to pick a function that's already in the lattice package. And I don't know if you may not have seen this trick before, but packages often have functions that are what are called hidden functions. So they're not exposed to the user, but they're still there. And in this case, the lattice package has this hidden function called extend limits. And so lattice functions that you have access to, like xyplot, those functions will call the hidden functions like extend limits. But if you tried to just load the lattice package and then use the function extend limits, it would say there is no such function. So what you can do with these hidden functions, if you know they're there, and you have to do a little bit of detective work sometimes to figure out that they are there, but if you know that there's a package with a hidden function that you want to pull out and have access to, there's this operator of three colons which will extract it. So I'm going to extract this hidden function from lattice, and you can see that there was something hiding in there, and I'm going to extract it, and I'm going to just give it the same name that that lattice gave it, which is extend.limits. Okay. And so now, rather than defining my x scale in terms of the raw range of the data, which was negative 2.3 to 2.5, now I can take that range and basically, this is a very simple operation, just add a little padding to it. I think it's about 10% padding. So again, you could have written your own extend.limits function, but that's just a handy one that's already there. Plus, I wanted to show you that in case you ever do see this 3 colon thing, now you hopefully have some idea what that's all about. So. Okay, so now what we just did there was we created a grid viewport, and we used a lattice function within the grid viewport. Now let's go and do kind of the opposite. And this is more like what you're likely to do in practice. Let's create a graphic with lattice, and then kind of add on to that with the grid functionality. So I'm going to go and do something kind of like what you've already seen, what we've already done with lattice. I'm going to create a scatter plot of y versus x with this fake data. And my panel function is basically going to say, okay, create your usual lattice scatter plot. But now within my custom panel function here, after you make the scatter plot, I'm going to use a grid, some grid functionality to annotate that scatter plot. And this is one of the practical ways that I actually do use grid on a not infrequent basis. Just to basically extend what I can do with lattice. So let me go ahead and execute this, and then you'll see what we're doing here. It's kind of a silly example maybe, but you can imagine doing things like this. I created a little annotation that's pointing to the data point with the minimum x value. And if you think about how would you position that text there? You have you could do what people often do, which is just first make the plot as is, and then kind of read the value off here, and this looks like it's about -3, and you could position it that way. But if you want it to work in a more automated fashion, like if you want it to be code that you're going to reuse in the future, for something like this, what you probably want to do is use this mixed coordinate system that you can get with grid. So the vertical positioning, I probably want to be, first of all, relative to the available plotting space. So I'm making it 5% of the way up the y-axis. And I don't necessarily want it to be a function of the data. So in this case, it's not. It's just no matter what data I put on here, my text is going to be positioned 5% of the way up the plot. So that y coordinate does not depend on the data, but maybe my x coordinate, I do, in this case, I want that pointing to that point. So that is a function of the data, and my native coordinates were specified in terms of the data. So I can position that exactly at the same x value where that's associated with the point. So hopefully, I don't know if it's clear immediately, but I think if you think about that, you'll see that this is showing the value of mixing different types of coordinate systems. And then I can rotate it and justify it as well. So that's that. So that's how you can, and again, that's probably what I do most, that's the way I use grid most often, is to do my own extra custom things within a lattice graph. Okay. All right, so that is units and viewports for you. Let's go on to the next concept, which is layouts. A layout you can think of as it's kind of like what the multi-panel plots that we got with using lattice. They have you can imagine those are based on basically dividing up all the available graphic space into sub-rectangles and then working with it within each of those sub-rectangles. So a layout is going to do the same thing. Let me clear the page. I'm going to make a grid layout object. In this case, this means three rows. Oh, let's see. I think that means 3 columns and 3 rows. Row 2. Actually, it means 3 rows and 3 columns. And now I'm going to push on a viewport. Again, think of that as pushing on a transparency. And this viewport also is going to be the same size as the viewport that was already there, but it's going to have this extra attribute associated with it, which is a layout. And it doesn't show you anything, but you just have to believe that it's there. If you look at the current viewport tree, you can see that I have added a new viewport, but it's not doing anything visible yet. Let me create x limits and y limits using that extend.limits function that I showed you a second ago. And now I'm going to push on another viewport. And let me just do this, and then I'll come back and explain in a second. I'm going to run this. I'm going to just kind of, to reassure myself that I just did something, I'm going to see that I did add this other viewport here. And now this is where, like I said, when I'm trying to figure out what I'm doing, prototyping, often I'll use this grid rectangle, because this is going to put a rectangle around my current viewport that I just added. Okay? And so what you can see is this square here takes up the middle third of the vertical space, and it takes up the first third of the horizontal space. And that's because back when I made my layout, remember I made it a 3x3 layout. And then in this step here, I said, I want to put another transparency down, but this is going to be smaller than the master transparency. This is just going to cover the part of the layout that corresponding to the second row. That's why I'm 2/3 of the way up, and the first column. Okay? So that's how I zoomed in on this particular space. And now within this particular space, I have a coordinate system, a native coordinate system, that's based on the x-lim and the y-lim. And because that's my native coordinate system, I can, again, use my panel.xy plot to draw within that coordinate system. Okay? So it's the same data that I plotted a minute ago. Back then it was taking up the whole graphic space, and now it's just taking up this this region here, which is 1/9 of the total plotting available plotting space. Now here's where it gets a little tricky. Now suppose I want to well, let me put it this way. Everything I do, and until I change my viewport again, everything I do is going to be within this little rectangle here. If I want to pop back out to the master viewport, I have to pop off my most recent viewport. So let me do current VP tree again, and you can see I've got this one where I'm drawing is stacked on top of this one, VP3, and that's stacked on top of root. Now what I can do is I can pop off the top one. It's a stack, and you pop things out. You push the things on or you pop them off. So I'm going to pop off my current viewport. And now let me look at the VP tree again. See, now I've just got these two. And so where's my reference area now? Well, I can, again, figure that out by putting a grid rectangle around my current viewport. And you can see now I'm back out in the master, the full plotting space, because VP3 had that whole area. I could then zoom in on a different component, and I don't know why I didn't do this actually in the script, but let me just do it quickly now. I could, let's go to a different part of this layout. I'm going to copy this. I'm going to just put it down here. And I'm going to change, let's go to row 2, column 3, and then do the same thing. So I'm going to push on another viewport. I'm going to look at my VP tree again. You can see now it knows that it's already used up something called VP4, so it's stacked on something called VP.5. And now I can do the same stuff I did before and put it over there, okay? Okay, so I see there's a question. How do I add the name of X and Y axis in this plot? That's a good question. I think I kind of get to that pretty soon. Let me see. I'll get you partway there, and then you can, let me get through this next example, and it won't quite answer your question, but it'll give you some idea, I think. Anyway, that's how layouts work, okay? Actually, let me say this in response to this question about how would I add the name of the X and Y axis in the plot. If you think now think about the difficulty of what lattice usually does. If you have a multi-panel display that's 3 rows by 3 columns, it doesn't just divide the plotting space into a 3 by 3 layout, because it also has to leave room. It has to leave a little bit of room on the margin for the X labels and for the Y labels and the tick marks and all that. So the layouts that Lattice uses are actually pretty complex, and they include a lot more rectangles than simply, it's not just the number of panels. There's a lot of, each of those little strip areas where you have the strip text for a panel, that's its own viewport. So one way of answering the question, how do you add the X and Y axis to the plot, is a lot of work, okay? You have the concepts already. You can just divide up the screen into layout elements, but when it actually comes time to doing it, if you're doing it with grid primitive functionality, it's going to be a lot of work. Having said that, let me go to this next example and see if this helps give a little bit more understanding. So I'm going to clear the page. I'm going to create a layout that has 2 rows and 1 column. And now I'm going to introduce another kind of unit and another kind of unit operation here. Well, first of all, I have sorry. Let me do a couple. Let me draw a couple things and then come back and explain what I've done. So I'm going to create this layout. I'm going to push on a viewport that has that layout. I'm going to go into the first row of that layout. So now that's my working area. And now within, and let me just add a grid rectangle here to give you a frame of reference. So, actually, sorry, I'll do this up in the script. Okay, so you can see up here, I've put a box around some top region of the plot. Put a rectangle around it, rather. That region is 1 centimeter tall. And that's because that's what I specified here. This says that the first row should have a height of 1 centimeter. And the second row of the layout should have a height of 1 null unit. What a null unit is basically, it means all the rest of the available space. So whatever it is. So everything from this line down to the bottom of the plotting region, that's considered 1 null unit just because that's what's left over. If I resize the the device, the meaning of the null unit is going to change because now that I made it bigger, there's more space left over. So the meaning of that null unit just changed, but of course 1 centimeter is 1 centimeter, so the height of this top box is not going to change. All right, so now that I'm working, remember this was the last viewport I pushed on, was this top one, row 1. Now that I'm working in that plotting area, if I add some grid text, by default that's going to get centered in the middle of my current viewport. So I can say this is my title. Now I can pop out of there, so I'm going to pop out of this top region. And now I'm going to dive back down. I'm going to push on a viewport corresponding to the second row of the layout. And I'm going to give those, I'm going to create scales that are based on the data, like I did before. Okay? And now I can make my scatter plot. And now there's some stuff that, when it comes to like creating labels and axes and all that, sometimes you can find the right stuff in Lattice that will kind of make your life a little bit easier. And for adding an axis, that's an example where there is something there already. By default, Lattice's panel.axis function makes an interior axis, so it's inside the plotting region, which is nice because I didn't leave any margin. If I had left a margin down below, I could have told panel.axis to draw the axis labels, tick marks and so forth, outside of the plotting region. But by default, it's going to draw it inside. I can do that on the left as well. And if I want, I can put a rectangle around all that. Just maybe to be clear, I'll make this LTY equals 2, color equals blue. Let me make it thicker too. Okay, so you can see that's where I was just drawing, right? Okay, let me see what my next thing is. Yeah, I think actually this is a good breaking point. So just to restate what I've already said, you can tell, obviously, that if you go down this road, you're potentially creating a fair amount of work for yourself if you try to make things by scratch. And I don't anticipate that you're going to want to do that very often. But again, where this is more useful is if you're looking at, if you're trying to figure out what lattice is doing and maybe extend it a little bit, or you're trying to figure out what ggplot is doing and extend that a little bit, that's where it's helpful to understand these basic grid concepts. They're probably not as useful, unless, I shouldn't say that. Unless you're really willing to invest a fair amount of time, you're probably not going to use the grid commands to do everything from scratch. Okay. So what I think I'll do for next time is, I'm still debating, to be honest, but I don't think I will do this remaining example. What it is maybe just to show you quickly what the result would be. There's a package called HH, which I can't remember their names now, but you can look online to see the authors. These guys, a couple statisticians who just wrote some graphics functions that they thought would be handy for analyzing adverse event data. And there's a plot that, here's one that they have built in called AE.plot, okay? And it makes a thing where it's got event rates for maybe these different letters correspond to different studies, and you've got an event rate for treatment A and treatment B, and then you've got a relative risk for each of those, and a confidence interval. And so this, I agree, this is a handy plot to have, but this doesn't give you that much flexibility. This plot doesn't. Like if you wanted to make, have the panel on the left take up more space and the panel on the right take up less space, it doesn't give you that flexibility. If you did care about that, you might want to construct something like this sort of by hand. And what I start to sketch out in the remainder of the code in this script is a way that you could do that using grid primitive functions. This is just a sketch. It doesn't add all the nice margins and labels that you might want, but it gives you an idea of how you could do that. But I think what I'll do is I will leave that to you. If you want to work through that example, go ahead. And what I'll try to do next time is address some of the questions that have come up that may not have been very well addressed in some of the other plotting sections. I know one example that I can definitely cover is what do you do if you want to add model predictions where those predictions weren't computed in R? That's something that you would frequently want to be able to do because you might be generating your predictions in non-mem or something like that. So I can cover an example like that. Also, if you guys have additional types of plots that you want to see if I can show you how to make them, feel free to submit those over the next couple days. Tell me what you're trying to do. No promises. Maybe I won't have an easy way to do it, but maybe I will. So I could try to cover some of those requests as well. So anyway, so we are meeting on Friday. It's going to be kind of miscellaneous. It's going to be kind of driven by what you guys want to do. But hopefully we can learn a few more useful graphics tricks. Okay, I will post this my revised script here. I don't think I've revised too much, but I will save this and I'll post it. And that's it for today. I'll hang on the line for a couple minutes if you want. And I'll talk to you Friday. Thanks. Bye.